Hello everyone, I'm Daisy Sharma from the Department of Computer Science, USDM, and today my topic is under the subject Relational Database Management System, which is in BCA third semester, and the topic to be discussed today is mapping of ER model to relational model. So let's start now. Now, this mapping of ER model to relational model, it is very important topic to discuss as in the field of relational database management system. This model, the relational database model, here this ER model is mainly used to discuss about the relationship between the entities. Now, my topic, mapping, is going to discuss about the transition from ER model to relational model. So let's see now what is the mapping concept here. Now, firstly, why mapping is needed? If we see mapping, this mapping is mainly used to convert the tables which are available in the relational model, that tables are converted from the ER diagram. That is the first objective of using the mapping, as well as it's because the relational model can be easily implemented by using different softwares like of Rdbms like Oracle, MySQL, SQL Server. So these are the available softwares of relational database management system. So in this softwares, we can implement directly by using this concept of mapping. Now here is an example of entity relationship diagram. In this example, if you see here, this square boxes, or we can call them as rectangles also. These rectangles or square boxes are known as the entities. The diamond shape, or we can call them as parallelogram also to some extent. So, or rhombus, sorry. So, this rhombuses or this diamond boxes are called as entities. This oval shape are known as the attributes, and here some of the attributes are having double oval, so they are called as multi-valued attributes. Now here this model, this ER model is having four entities, and the entities are travel agency, customer, service and payment. These four entities here are related by the relation. Now for example, the first thing, travel agency and customer. These both entities are related by using this relation travel agency. In the same way, customer is related with service, the other entity service, by using the customer ID. Then service and payment are related to each other by using the service ID. So here these are the relationships, these are the entities as well as these are the attributes. So this is an instance I have given here to show the ER diagram, and based on this type of ER diagram, now we can make the tables, and that is the mapping concept today we are going to discuss. So now let's move to the next slide. So there are some actually rules, the rules based on which we can do the concept of mapping. The first rule is for strong entity set with only simple attributes. So it means strong entity means the entities which are having the primary key mainly. So these are called strong entities. So the strong entities, when the strong entities are having only simple attributes. So in this case, now this will require only one table in a relational model. So only one table is required to make in case of the relational model, and the attributes of the table will be the attributes of the entity set. So the attributes of this table will be, now if we see this example here, now this is one entity, student, and in this entity student we are having three attributes. One is roll number, which is underlined. It means actually what? It is the primary key. Then next is name, and another one is gender. Now we can consider this student as a strong entity because it is containing one primary key, and the primary key in this entity student is roll number. So the rule number 1 can be applied in this example. And when we apply this example, when we apply this rule over this example, we can make a table of student. This is the table of student where we are having this three attributes as three fields directly. Roll number from here, name from this one, and gender from this one. And this table is the student table. If we see the rule here, now again we see here a strong entity set with only simple attributes will require only one table in the relational model, which is implemented here. This is rule number 1's first point. Second point, the attributes of the table will be the attributes of the entity set. So here these are the attributes of the entity set, and then the primary key of the table will be the key attribute of the entity set. So that means this is the primary key, and this entity set primary key will be directly the primary key in the table. This is the concept which is used here in rule number 1 of mapping. Now let's move to the next one, that is rule number 2, which is having a strong entity with composite attributes. Now composite attributes. Now if we see this, let's go to the example first, then we will come back here to see the rules under this point. So in this example, if we see, we are having this student entity, and in this student entity now we are having various types of attributes. One is roll number, which is the primary key here. Then name. This name is the student name, and student name can have two parts. One is the first name and one is the last name. So when we are having this first name and last name, both of these two names can combine together to make the name attribute. So this is the concept of the composite attribute. Same thing here. Now address, which is consisting of city, street, and house number. Now if we have this type of entity as well as the attributes, so at this point of time we have to use rule number 2. So as per rule number 2, strong entity with composite attributes. So point number 1, a strong entity set with any number of composite attribute will require only one table in relational model. So there will be only one table. If we see here, there will be only one table. And what are the contents of the table here? Let's go to point number 2. While conversion, simple attributes of the composite attributes are taken into account and not the composite attribute itself. It means now if we make the table from the student entity, then okay, roll number will come directly here, but instead of name, it will be what now? It will be the first name and last name which will be coming directly in the table instead of name here. Name will not come directly. Instead of that, inside this name is composite attribute which is consisting of first name and last name. So this first name and last name will come here in this table. In the same way, if we see this address is consisting of city, street and house number. So this city, street and house number will come here in this table instead of address directly. So this is rule number 2. Next, let's move to rule number 3, where we have the strong entity set with multi-valued attributes. So what does this multi-valued attribute? To see this, let's move to the example here. If we see this example now, here we are having the student entity again with roll number, city, where roll number is the primary key, but mobile number here is the, we can call it as multi-valued attribute. Why multi-valued attribute? Because one student may have more than one mobile number. So this is the multi-valued attribute. More than one value can be present here. And the symbol of this multi-valued attribute is double oval. So as per the rule here, let's move to the rule point number 1 of rule 3. Here it is saying here that a strong entity with any number of multi-valued attributes will require 2 tables in a relational model. It requires not only one table, it requires 2 tables. Okay, and the first table, the one table, will contain all the simple attributes with the primary key, and the other table will contain the primary key and all the multi-valued attributes. So here now, since 2 tables will be made, if we see this example, these 2 tables are made here. So in this example, firstly it will take the student's roll number and city, which is the simple attribute consisting of this 2. Now this first table is made, and the other table will be, table number 2 will be, again the roll number will come here, but along with that there will be the mobile number. But one thing should be remembered here, that in the first table the roll number is the primary key, and in the second table roll number is not the primary key. This roll number is actually the foreign key, which is taking the reference from this roll number, because as per the rule of primary key, it cannot be null and it cannot be same value. That means it should be unique value. And in case of this roll number, this is foreign key. If it is the foreign key now, so foreign key can have multiple values. The same values can come multiple times, but it is totally referenced with the first table's roll number. Now, for example, if the first table we call it as student 1 and the second table we are calling it as student 2. If we give the names like this, now student 1 table, if this student 1 table is having the roll numbers like 1, 2, 3 and 4, then in the student 2 table, only roll numbers will be present 1, 2, 3 and 4, but it can be present for multiple times. So this is the rule number 3. Now let's move to rule number 4. So as per rule number 4, translating relationship set into a table. So for this now, translating relationship into a table, let's move to this example. That means here now we are getting that already from the entities we can make the tables. We are getting this now. But in some cases the relationship can also become a table. So what are the rules to make this relationship, this diamond box, as one table? So rules are given here. So here we see, if we see here, a relationship set will require one table in the relational model. Attributes of the tables are, firstly, primary key attribute of the participating entity set and its descriptive attributes. The non-descriptive attributes will be the primary key. Now here if we see now, in this example, this employee is having the primary key, this is the entity. Employee is having the primary key employee number. Department is having the primary key department number or department ID. Now this works in is the relationship and it is having its own attribute, that is since. So when we make this table of works in, we can make the table of works in, but in this works in table, only since cannot be the attribute. Along with this since attribute, there must have the attribute of the participating entities, that are employee number, which is coming here, and the department ID, which is coming here. And along with that since, which is its own attribute, will be coming. So this is the table. But here one question may come in your mind or our mind, like how the employee and department, these two can be the entity, these two entities can be the table or not. Yes, these two can be the entity which will be becoming the table. And along with that, works in will be another table, which is consisting of these things. Now we have to, these things are given here. That means there will be total 3 tables in this example. One is the employee table, one is the department table, and another one will be the works in table. Now, next, rule number 5. As per rule number 5, the binary relationships with cardinality ratio. Now, based on the cardinality ratio, now, before starting about the cardinality ratio, so cardinality ratio means actually what? In our relationship, when we are having the relationship, the two entities are participating in the relationship, there can be 1:1 relation. One entity set can participate with only one entity set of the second one, or 1:many, many is to one, or many is to many. So this is to, that means this ratio is called as cardinality ratio, and this is very important thing in case of PR diagram. So based on these cardinality ratios, now the mapping can be done, and this mapping are divided into 4 different cases. Case 1, case 2, case 3, case 4 under rule 5. So if we see now case number 1, where for the binary relationship with cardinality ratio m is to n, means many to many. So here m is to, not m is given here, it is given here as m is to n, because if m value is 5, this side it cannot be, it may be 5, it may be 10, it may be 2, but more than 1. So that's why the same m is not used here, it is used here as n. So in this relationship, or in this example, A and B, these two are the entities. A is having the primary key A1 and B is having the primary key B1. Now along with that, A is having another attribute A2 and B is having another attribute B2, and the relationship name is R. So here now, when we are having this m is to n relationship, then in this example, A will be having a table which is consisting of A1 and A2, where A1 is the primary key. B is having another table B1 with B1 and B2, where B1 is the primary key. And in case of m is to n relationship, this R will also become a table which is having the primary keys of A and B, that is A1 and B1, and togetherly they will make the composite key, which is another form of primary key, or we can call it as extended primary key, where combination of the value of A1 and B1 will make the primary key, which is known as composite key. This is the relationship of m is to n cardinality ratio, which is case number 1. Now move to case number 2. Case number 2 is for 1:n. So 1:n here. Now A and B, same example we are taking, nothing has been changed, only the relationship, that is 1 and n is changed. This is the cardinality ratio 1 and n, 1:n. So in this case, now we consider n side as the stronger side than 1 side. So here what will happen now? First table will be A. First table will be A, and A is having its own attributes like A1 and A2, where A1 is the primary key. But B will take the relation R, and here BR along with this now. So in in BR now, excuse me, it is consisting of B1, the primary key of B, B2, another attribute. Along with that, A1 will come here as a foreign key. So one thing is given here as note that here combined table will be drawn for the entity set B and relationship set R. That means combination of B and R will become the table, where A1 will be the foreign key. But note that A, which is having the cardinality ratio 1, cannot take B1 as the foreign key here. It will only take its own attributes. A will take only its own attributes. So this is cardinality ratio 1:n in case number 2. So case number 3 is just opposite of case number 2, where A is now having the relationship M, cardinality ratio M, and here B side is 1. So the stronger side is A. So that's why now A is combining with R with the value A1, A2 and B1. So A1 is the primary key and B1 is the foreign key here, where B is the next table which is having no any other foreign keys, only its primary key B1 and B2 is the normal attribute. And next is case number 4. So the case number 4 is now the binary relationship of the cardinality ratio 1:1. So in this case, both are the weaker side. So two ways can be applied. One is if A is combined with the relationship R, then the attributes will be its own attributes A1, A2, and along with that B1 can come as a foreign key. And if it is coming B1 as a foreign key in AR, then B cannot take the A1 as the foreign key. So at that time, it will be B1 and B2 only. This is way number 1. And in way number 2, if we see, A is now only taking the attributes A1 and A2. Now B can combine with R, B can combine with R. Now at that time, the values will be B1, B2, and then the foreign key A1 will come here. So these two ways are here, and we can implement any of this way, not two of the ways together. So this is in the case of relationship cardinality ratio with 1:1. Next, rule number 6. For binary relationship with both cardinality constraints and participating constraints. So cardinality constraint will be implemented as discussed in rule number 5, as we discussed in rule number 5. So now, because of the total participating constraint, foreign key acquires not null constraint. That is, now foreign key cannot be null. Normally foreign key can be null, but when it is having total participation, so at that time foreign key cannot be null. Now if we see here this example, so in this example, this double line is representing the total participation. It means that if A doesn't exist, then B cannot exist. So in this now, though it is 1:n, now here we combine the entity set B with relationship R, and then the two tables will be A with the value of A1 and A2, where A1 is the primary key, and B is combining with the relationship R. Here B1, B2 along with this A1 is coming as a foreign key. And because the total participation foreign key A1 has acquired not null, this A1 is acquiring not null constraint, so it cannot be null now because it is fully dependent on A. B is fully dependent on A. So this much for now, and these are the total rules of the total 6 rules of the mapping. And another one case here, case 2, this is case 1 for the fully dependency rule, and now here for the binary relationship with cardinality constraint and total participation constraint both sides. Now if both sides total participation is there, then this relationship R have the table ARB, which is here A1, A2 B1, B2. So all these are coming all together. So this is the relationship R along with A and B, and along with A and B, it's all the attributes will come. So this much, this is the concept of mapping, and all this mapping concept now, here we can make the tables based on this mapping concept, and whenever we make the the logical tables here, now these tables can be implemented in diagram or in the other other software concept. So this much for today, and let's see now the rough revision. If we see, let's see the rough revision now. So what are the things we have discussed? Firstly, why mapping is needed in case of relational database management system. Then I have given a simple example of one diagram so that we can understand the concept of diagram. Next, the rule 1. This is for strong entity set with simple attribute. One example is given here. Then rule 2 for strong entity with composite attribute. Then rule 3 is strong entity with multi-valued attribute. And strong entity means the entity which is having the primary key. Then rule number 4 is now translating relationship into a table, where here relationship can be the table now. And after that, rule number 5 is based on the binary relationship with cardinality ratio. So 4 cases are there, that is m is to n, which is given here. Case 1, case 2, 1 is to n. Case 3 is m is to 1, and case 4 is 1 is to 1. Now, rule number 6 is about the binary relationship with both cardinality constraint and participation constraint. So here also this is the first case where one-sided total participation is there, and another one, case 2, where both-sided total participation is there. So this much for today. Now I'm going to close my slide over here. Hope you have understood here. So thank you so much. Thank you for listening. Hope it is giving you the benefit in the future part. Thank you so much.